Hi guys, thank you for being here. I know there is a keynote happening as well, so we appreciate taking the time to be with here today. And we're really excited to talk to you about how you can take RAG to the next level with the Data Cloud Hybrid Search. And before I start, I wanted to show you a very important slide, and I hope you have memorized this slide by now, because I'm sure every presentation that you've been to in the last 3 days starts with this slide. Now, a more interesting slide. We're in the age of AI, right? So instead of me doing a boring intro, I am going to ask Einstein to introduce today's 3 speakers. So I'm Franny. I am a distinguished AI architect here at Salesforce. I have been building AI solutions and advising customers on their AI transformations over the last 24 or 5 years, right? And so today we want to talk to you about the latest RAG and search innovations. Wow, it's parties happening. So, I actually forgot that I need to show you a demo. The music threw me off. So let's start with a scenario. I am an insurance policy advisor, okay? And my job is to listen to my customers' questions, answer their queries, and if necessary, recommend the right insurance policies for them. So when you think about it, right, let's now look at a live demo. Oh, what just happened here? Okay, I hope you can see the screen. There is the actual policy there. So imagine my customer is calling me and they're asking about whether their current policy covers broken glass. Now, if you know the power of RAG through semantic search, you know that, glass, broken, and, similar terms, RAG can do a really good job of finding the relevant policies and passages to help me answer that question. But what you notice in this particular question is also the customer is giving me their policy name. Now, when you think about a policy name, it's usually a combination of letters, numbers, and things like hyphens and dash and things like that, right? So if you do a semantic search on a sequence like that, you're not gonna get the kind of match you're looking for. So for example, the first part, broken glass, I'm gonna find some matches. But what I really want in this scenario is the exact match of my policy name, right? And this is when, if you look at the table on the bottom of the screen, on the right-hand side, you have the vector scores. And this is the result of semantic search. And if you see the top chunk, which is number 1, ranked number 1, it starts with home assist, which is the name of the policy. You can see the vector score is actually number 3 out of the 10 that you see in that table, right? Do you all see that? And the top vector score is actually number 4. So if you just rely on vector search, it's not going to give you that match you're looking for. But if you look at the keyword search score, you notice because of the exact match of home assist, that top chunk is actually ranked quite high in the keyword search. And so hybrid search combines the both scores and gives you the best of both worlds. And this is how we're able to bring up that particular chunk that mentions home assist to the top of your query result. Does that make sense? And this is why you really have the best of both worlds. So if I go and talk to you about how you can now leverage the results from your hybrid search, right? So what you see here is what we call Einstein Studio, and that is currently accessible in Data Cloud. So when you go to Einstein Studio, this is where you configure all of your models, but you notice a new tab called Retrievers. And this is something that we shipped in late August, where you can actually now leverage semantic search and hybrid search with this no-code retriever. And I'm going to show you how easy it is to configure a retriever. So you click on this new retriever button, and you can see that it's a very easy 4-step process. You first specify the data space, and then you go select the search index, which Dallas will take you through. But once you have the search index, you have the option to configure some filters. But after that, you pretty much just review and save. So you have a retriever now that can actually leverage both keyword search and semantic search. But how do you then ground with that data? And I hope you're all familiar with Prompt Builder. Yes, you've all seen it, play with it. There's a lot of hands-on today. So when you go to the Prompt Builder, here I have a prompt open for you. And you notice I already have the no-code retriever here that I'm using to ground my prompt with. And to insert this, and I hope you're familiar with the resource picker where you can select the merge fields and flow to ground your prompt with. Very similar, you go to Einstein Search and you're able to see all of your retrievers that you've configured in the previous step I just showed you. So when you do that, what happens is now I have a user query, and this is the exact query that we saw before. Does my policy cover broken glass? And when you run that, you're able to leverage the no-code retriever that will look at both your semantic search results and keyword search results and use that to retrieve the relevant policies and passages in the policies to help me answer that particular question that my customer has. So with that, I'm going to introduce Dallas to the stage, who will take you through the search index.
Thank you. All right. So RAG powered by hybrid search and data cloud. Now, wasn't that an amazing demo? Thanks, Franny. All right, I'm Dallas. I'm an engineering manager at Salesforce, and today I'm going to talk about a little bit about what happened under the hood here. So Franny showcased a few steps in order to create your search retriever. One of those steps was selecting a DMO, and the second step was selecting a search index on that DMO. So let's take a quick look at how to create that search index for your retriever. So in order to create a search index, you first go into the search index page in your Data Cloud application. You click on the New button, and you're presented with a couple of options. One of those options is called the Easy Setup. The Easy Setup is just like it sounds. It's pretty easy. You go through it, you select the DMO that you want to base your search index on, you give it a name and hit save, and you get a search index. As simple as that. We take care of all the default configurations for you under the hood, so you don't have to worry about a thing. However, but that's not what you're here for. You're here for the advanced setup because you're trying to understand what else you can do with your search index. What are the other configurations you can add to it? I'll take a guided tour of how to actually create an advanced search index for your application. So you see a few steps here. One of those steps are selecting the type of search index you'd like to base your retriever on. The first option there is a vector search, which gives you the goodness of a vector database. It's really good at semantic matching, understands words, does a really good job there. And then there's hybrid search that Franny was talking about. Hybrid search gives you the semantic goodness of the vector database as well as the exact matching capabilities of the keyword search index. And both of those together can help you understand product codes and along with semantic meanings and other things. So in this case, I'm going to select hybrid search to begin with. Remember, hybrid search is beta right now, and it'll be GA sometime in November. All right, the second step is trying to select the source object. So you have to select the DMO here. I'm sure by now, if you've already gotten to this point, you know exactly what DMO you want to base your search index on. So I'm going to select one of these just for demo purposes and move on to the next step. On the next step, you select fields to chunk. Now, this is interesting because once you select your DMO that you want to search on, you also want to understand which fields you want to actually have that retriever search on. Now, this is important because you select only those fields that are semantically rich in information, something that you really want to. So if you're a knowledge user, things like title, description, maybe content, body, or if you have PDF files, something that's really semantically rich should go into the chunking process here. As an example, I'm going to select a couple fields that I think are really important for my use case. That'll be policy and name, and I'll click save, and then I'll move on to the next step. Now, vectorization strategy basically helps assess the semantic closeness of all the words in your index. So here, there's a couple of options right now. There's the E5 large V2 by Hugging Face. Very soon, there'll be the multilingual model as well available for hybrid search, so it can understand different languages as well. For now, we'll select the default that we have and move to the next step. Filters are very interesting. This is when you run your search query, you would like to filter on certain fields. Like for example, if you're a knowledge user, you'd want to maybe base your retriever on only published articles. So at that point, if you have a published status or something like that, you would want to add that to your filter. You can also add specific product codes and do ands and ors with your filters once you have them configured in the search index. In this case, just as an example, I'm going to select the published status for the filtering, and I'll also show you in the SQL query exactly where you can leverage this filter. That's an optional stage just for reference. The next one is ranking. So this is also an optional setup. Ranking factors can help you influence ranking in this case. So we have a ranking algorithm, and if you want to give a hint to that ranker based on popularity or recency in this case, you can do that. Now, for example, popularity is think of page views or likes or something that your knowledge articles or your content might have that indicate popularity. So if there's multiple records that have similar content, but you want to boost one or two or the others based on maybe page views or likes, you can do that as part of popularity. Same with recency. If you want to boost maybe the most recently created or the last modified articles or something like that based on those fields, you can do that. And you can give that hint to the ranker, and a ranking algorithm will take that into consideration. For example, I'll take recency, I'll select the DMO and the field. In this case, maybe I'll choose the last modified because I want the most recent articles or content to be boosted as far as ranking goes. Moving on to the next step, let's take a pause here and review what we've done so far. We've selected the source DMO, we've selected the search type, we've selected chunking fields, we've selected vectorization, we've selected fields for filtering and ranking factors, and it creates two target DMOs for you. One is the chunk DMO, which will have all the chunks, and the other one is the index DMO that stores the vector embeddings. Once you have all this, you hit the save button and you get a search index. I'll quickly show you what you can do with that search index once you have that ready. As an example, here's a very simple search query that you can run in order to test everything works fine. The format of this looks like you do a select star on a hybrid search table function with your policies DLM index DMO that you just created. And here's your here's your query, which looks like, in this case, is does my policy cover fire hazard? I have the policy landlord biz. So this is what I want to look for. And the next one is filters. Is the filter that we just created while creating the search index. Published status. So I would want to filter something like maybe all published articles in this case. And how many results do you want back from your query? So that's where this goes. So this is a very simple search query that you can execute. But this doesn't give me the chunks to inspect what really comes back from that query. So I'm going to make a little bit more advanced query in this case where I am going to join the same query on my search index with the chunk DLM. So in this case, I'm going to join my search index with the chunk DMO to try and inspect what exactly comes back from my query. So I'll select the chunk, the hybrid score, keyword score, and the vector score. So I'm going to select all of these scores along with the chunks, and I'm going to join my index DLM with my chunk DLM on record ID, and then I'll order it by hybrid score in a descending order. So let's see what comes back from this query. Does my policy cover fire hazard? I have the policy landlord biz. Now, if you take a look at this, the vector engine thinks that the second record is the most important because it's looking for probably fire hazard and other things, and it understands the semantic meaning of your content and the query. However, the keyword engine understands that you're looking for a specific policy, which is landlord biz in this case. And it gives that policy a higher score. So you can see the keyword score is a little higher for the first record. And both of these scores, the vector score and the keyword score, goes through a fusion ranker, and the fusion ranker takes a final call and sends out a hybrid score, which in this case, it ranks the landlord biz chunk higher than the others. So that's how hybrid search can really help out. It understands semantic meaning as well as product codes, policies, numbers, anything else that might be relevant to your business. With that, I'll pass it along to Paulo, who will talk a little bit about why hybrid search and our roadmap going forward.
Thank
Thanks,
you.
Paulo.
Thank you, Dallas. Hello, everyone. I'm Paul Gomez. I'm a product manager working on hybrid search. And Franny told you give you an idea of to use hybrid search. Dallas talked about how to create the search index that is necessary for hybrid search. I'm going to close the presentation giving an overview of the complete process here of hybrid search. But I would like to start with the why are we doing this? Why do we need to ground the LLMs? And hybrid search is basically a way of grounding the LLMs, which is giving the relevant context to the LLM so that it can generate the right answer for the customer. There's three main benefits that I would like to call out, which is first one, and the most important one, is that with grounding, you enable the AI to give you the right solutions. You're giving the relevant information to the LLM so that it can give you the right solution. That's the main advantage there. But there's also other advantages like citations. Citations are very important to instill trust into the user because the LLM can associate the sources that it uses to generate the answer and thus gives you that information that you can put in a blue link in your answer, and the users can click it and inspect it. And thus it gives the user the trust that they need to trust the answer that the LLM is giving. The last benefit that I would like to call out is that with grounding with the latest information that is giving the most up-to-date information to the LLM, you don't need to retrain the LLM, which is a costly process. So it's more cost-effective and more efficient. But the main question here in this presentation is why hybrid search? You know that hybrid search combines both keyword search and vector search. And I'd like to answer that question dissecting here the query that Franny did in the beginning. So she had the question, does my policy cover broken glass? I have the policy home assist. So vector search is very good at understanding plain English. So the part where it talks about in the query about the policy, about covering broken glass issues and what is a policy, the concept of policy. What is not good about is understanding home assist. It doesn't know what it is. It wasn't trained on that, so it doesn't have the necessary knowledge to answer that. So that home assist in the query is like noise. And sometimes this noise hinders the results that a vector search returns. That's a limitation from vector search. And the way that we can solve this is by using keyword search to also influence the ranking of the results. Because with keyword search, you can do exact match. And that's exactly what we want. We want at keyword search look for documents that talk about home assist policies. So you get vector search that ranks higher documents that talk about broken glass and if the policy covers it or not. And you get the keyword search to get you the right type of policy on top of the result. So when you mix these two, you get the best of both worlds, okay? And you get the most relevant results. Now, how does this work? So basically, there's three main stages here. The first stage, which is the ingestion of data, which is the yellow boxes there, is the first step that you need to do. You need to ingest the data that you need to ground your LLM and get it into Data Cloud using the Data Cloud connectors and have it in the form of DMOs, data modeling objects, basically a table with fields and with the information that you need. That's the first step. The second step, which Dallas talked about, is about creating the search index. And it's basically three operations that the search index does when you click save, when you're finishing defining the search index. After you click save, the Data Cloud behind the scenes is going to do three things. It's going to chunk the data, basically get your documents or your knowledge articles, split them into chunks of data, into parts of different texts, usually around 512 tokens or words, and then goes to a second operation, which is you need to transform each chunk of data into a vector of numbers. And this vector of numbers is very important because It's the semantic representation of that text. It's the meaning of that text. And the last operation is that these vectors are indexed into vector search index. Now, for keyword search, we only need the chunks of data. So the chunks of data go directly to keyword search. So in the end, you have both vector search index and the keyword search index created and ready to be queried, which is the third part. So the third part is when your applications are going to call the hybrid search service and send a query. That query goes to the Hybrid Fusion Ranker, which is the main module inside Hybrid Search that coordinates the resolution of the query. And it's going to send the query both to the vector search and to the keyword search at the same time. They both will return the results, and then the Hybrid Fusion Ranker is going to re-rank the results and bubble up the most relevant on top. So in the previous case of the query, it's going to bubble up the pieces of text, the chunks that talk about covering policies about broken glass, and it's going to bubble up the policies that talk about home assist. So merging them together. And this is basically the main process here for hybrid search. How do you use it? So basically, there's two main steps here to use hybrid search. There's creation of the search index that Dallas shown with all those steps there that you can define, or simply you can also select the easy setup and just select the DMO that has the relevant information. And you can do this in two different ways. You can use the setup UI that Dallas shown, or you can use a pro-code solution, which is the Data Cloud Connect API and use directly with code calling that API. Now, the second step is you need to call and send a query to the hybrid search service. And there's three alternatives there. There's the no-code solution, the retrievers that Franny showed in a prompt builder. So you can use a retriever and with no code call hybrid search and get the results. But you can also use it either through the Data Cloud Query API or Apex code, and you can call directly the hybrid search. So these are the ways, the two main steps that you have to use hybrid search. Now I'd like to wrap up this presentation by talking a little bit about the roadmap. Currently, hybrid search is in beta. You can go to Data Cloud Setup, go to Feature Manager, and enable hybrid search. And basically, you have pre-filtering capabilities in the beta version right now, but you also have configuration options. You can choose the chunking strategy, the vectorization strategy, or you can define the ranking factors as Dallas showed. In November, we're going to GA hybrid search. We'll be providing more configuration capabilities, which is very important for you to optimize to your specific use case. You'll be able to select the ranking factor, which merges the results, and also the parameters that come with it. You might select more vector search or less vector search in your ranking of the results, and thus fine-tuning for your use case. The default option will be the hybrid search in the easy setup. We'll have multi-language support, and we'll have also monitoring capabilities so you can understand how hybrid search is performing and our users are using this functionality. And with this, I conclude our presentation. In name of the team that prepared this presentation, we'd like to thank you and hope that this was useful for you. Thank you, everyone.
Thank you. I know it's very loud, so thank you for staying with us.
Yeah.